So after the discussion of electric potential and potential difference, now we are eligible to understand the topic electric current. Yes, definitely electric current is the most essential part of our day-to-day life. I can bet you people, without electricity you even cannot survive, right? So what is electric current here? Yes, we have already discussed that the flow of electric current is equals to the flow of electric charge. Yes, so in a wire you know that in a wire electricity flows, right? So how does it flow? It flows due to the electrons flow in the conductor. Okay, any kind of conductor is having electrons inside it, and that electrons is actually a free electron. Okay, that is actually a free electron, and that free electrons whenever get the potential difference around it, so they will start move from one point to another point. Okay, actually the potential difference here makes a major role because it gives the push to these electrons and they will start moving from one point to another point, and due to the flow of these charged particles actually electricity produced. Our main motive is to make them move. Okay, and how we will make them move? Due to creating the potential difference here. Okay, once they start moving, they carry charge over them, so actually charged particles are moving. And once the charged particles are moving, so we can say that electricity is there, and that is a source of energy, that is the part of energy that makes the appliances work. Even you are watching this video over in your phone or laptop right now, and that works on electricity only. Without that you won't be able to see this video also. Right? So that happens because electrons here in the circuit of your phone or the laptop moves from one position to another, and the source of electricity is from the power plug. Okay, so that is how electric current works here. So you need to remember that rate of flow of electric charges is actually the electric current. How much charges are flowing from one point to another will gives you the quantity of electric current. If more charges are flowing from one particle to another, so more current will be there, and if less charges are there, so less current will flow. Now the measurement part of electric current, as we have seen that rate of flow of electric charges is actually the electric current. So by this we can formulate a formula here that the electric current is actually the total number of charges that is flowing in a particular time. So we can say that number of charged particles here that can be denoted by Q. Yes, charge can be denoted as Q, and time can be denoted as small t or capital T you can take. Okay, fine, it is fine in science that T is obviously denoted as T, time. So we can formulate like this, that I is the symbol here for the current. Okay student, so I is equals to Q by T is the formula to calculate the amount of current that is flowing in the wire. Fine. So let's suppose that the 5 coulomb of charges are flowing in a wire in a duration of 2 seconds. Okay, I'm just making a rough measurements here. So we can write here 5 coulomb and 2 seconds. Fine. So 5 by 2 is 2.5 coulomb per second will be the current that is flowing here in the current wire. Okay, and that current wire is actually not whole wire, dear all. That is also a misconception. You are not going to measure the length of the wire also now, because wire can be 1 meter long or 2 meter long. It could be anything. But the amount of current will be the same in the whole wire. Then how we will measure that much of current is flowing in the wire? What is the length of the wire then? Okay, so here we are not going to take the length of whole wire, we are just taking the cross section area. That is, if we cut it into a pieces and it cut in a very single slice. okay, very fine slice, and that will gives you the cross section. Like this marker is having a cross section area like this, okay. So this is the cross section area, and from this single circle, the amount of charged particles are passing in 1 second, okay, that is 2.5 coulomb for this case. So we can say that here the current is 2.5 coulomb per second. That is actually that amount of coulomb charges are passing in 1 second only. If the charged particles, that let's suppose we are taking another measurement, 5 coulomb per second, okay. So we can say now that 5 coulomb charges are passing through this cross section of wire in 1 second. So this current is more and this current is less. That does not depend on the length of wire, okay. So we can say that coulomb per like current is equals to Q by T. So this is coulomb per second. Coulomb per second is actually the current measurement, but due to the this is inconvenient to speak and again, like in case of volt also we are having joule per coulomb, right? But with a single term we can specify the SI unit of volt also, that is the volt, okay. So here in this case also we are having one unit, that is ampere. So this combinedly can be written as ampere, okay. So now you are, if whenever you are going to use the SI unit of current, you will use ampere from now onwards, okay. So in earlier case, like I was writing 2.5 coulomb per second. So in place of this we can write 2.5 ampere, that is capital A, and 5 coulomb per second. So I can write here 5 ampere again. So 1 ampere can gives you actually 1 coulomb per 1 second. That is the amount of charged particles, 1 coulomb charged particles flowing in 1 second through a cross section of a wire will gives you 1 ampere of current. Okay, mark my word, this one cross section area of a wire is very necessary to mention in your exams also. If you are not going to mention cross section area, then how the examiner will predict whether you are talking it about 1 meter of wire, 2 meter or 5 kilometers of wire. Okay, it could be anything, but actually nonetheless we are talking about the cross section area only. Okay, so here you have to mention that 1 coulomb of charge flow through the cross section or area of a wire in 1 second will gives you 1 ampere of current. Okay, and this question is very important. Most of the time in boards this question comes, explain 1 ampere current. Okay, so this is how you need to explain this thing. Yes, so some students combine the concept of potential and current again. So let me tell you this example again, that in this bucket, the pressure that is provided by the water molecule to move the water from one bucket to another bucket, that is actually equivalent to potential, and the water that is flowing, the stream of water that is flowing is actually current. If you can imagine, okay, bringing up your abstract knowledge here, so you can see that, you can imagine that here the water flows from one point to the another point. The water flows from one bucket to the another bucket. In the same manner, electrons flow from one position to another, and that electron flows is actually the current flows. Electron flows, current flows. Charge particle flows, current flows. Okay, so here current will flow is actually can be denoted by the water flows, but the pressure with which the water is flowing from bucket 1 to the another bucket is actually the electric potential. Pressure is equivalent to potential and the flow is equivalent to the current here. Okay, the stream of the water is equivalent to the current here. Okay, so now here is the devices that are used to measure the voltmeter and ammeter. Okay, so here is the symbol of voltmeter, students, and here is the symbol of ammeter. Ammeter is used to measure the electric current and voltmeter is used to measure the potential, that is the volt. Okay, and this is used to measure the current that is flowing inside the wire. Okay, and this again combined in the circuit or in any of the household circuit formations. We combine it in a series, direct in contact with the appliance. Okay, but this can be put as the parallel combination. Okay, I am going to tell you what is series and parallel combination in next upcoming time. Okay, but now you have to learn that this voltmeter is arranged in a parallel manner and this is arranged in a series manner. Okay, direct combined. We can say that it can be directly combined to the appliance through which you need to measure the current is flowing, and this need to put in a parallel manner over the appliance, of which you need to want to measure how much potential drop it is taking.